Hello there and welcome back to another day where I have some free time. And in this day's goal of developing Nobita, we would try to have multiprocessing or allow multiple commands to occur at once. Well, as long as the dependency chain would allow it. So that would be our goal for today. And let us start. So our first order of business would be to separate the waiting and execution of the child process from fork exec. First of all, before that, I should also add a type def of what the process used, what the processes use in Linux to be executed and be waited, and that is the process ID type. And I would just remap that to our own PID. Just a preparation for um the what do you call this again? The cross-platform goal. It's been a long time since I have free time. I am not used to this anymore. So fork exec should now return the process ID type, and I want to rename this to, instead of fork exec, to proc exec, and a wait function that would return the status of the process, which is done with the wait function. Now this would take a process ID and a flag whether it would pause the current execution. So I guess pause, or return immediately if the child process has not returned yet. Then what would be used by our build target would be not these two, but new functions that would use fork exec and fork proc wait automatically. So it this would return nothing and say proc append. So it would append this into the, well, a process queue maybe. It would take the same double argument pointers and two more functions that would wait until one spot in the queue is free, and the other would wait for all of them. So in proc append, it should also take the build thing, the build variable used by Nobita, since that's where I'll put the process queue list later on. So struct Nobita build this as well. Now, in preparation for this, I would add the vector for the process queue. So I can just rename this to, I guess, proc queue, though not a double void pointer, just a normal pointer to the process IDs. Now, fork exec would error out, well, the usage of it in here anyways, and rename this to proc exec, make this return the process ID, has been remapped by us, and this would take the build variable. Wait, did I do this wrong? Ah, no, I did this correctly, but this should not take the build variable. It's the append that will do that. And then I can remap PID here and initialize it to -1. Just return it. Then reassign that with the return value of fork. Then what else? The proc exec should not print it here. So, and it should not wait here. So just return the ID. Now we need another one for waiting. That would return the return value of the command of the child process. So that would be wait, not build wait, it's proc wait. Well, in either case that the build has already failed, we should still wait for the ongoing child process to exit cleanly. So I would not check if the build has failed here, but just run the wait PID normally with status being initialized to -1. So we will check that later on. Since there's a way for wait PID to return immediately if the process is checking on has not exited yet. Where was it? Here, it's no hang. So I think it would not mess with the address of the status integer if it returned immediately. So I think that is fine. So can run wait PID, the PID, and the address of status with the flag that if pause is true, then it would not return immediately. It would actually wait for the process ID to exit. So just zero that out. And if pause is false, then we can make it do with no hang. Just return the status, which can be checked later on if it's equal to -1 or if it's exited as well with the W macro. Next up would be the proc append. So this would not return anything. Append with um with a double pointer of commands that is terminated by null with the build variable, I think. Well, this might be a long video. Either way, first order of business. If the build has failed, do not try to add any more processes in here. Next would be if um, the process queue has more than or equal to the global variable that I have not defined yet, and that can be changed by the user, which is the proc count. Now, where did I define the other one? Um, the build failed here. I would add that next to this. So just a static integer, but maybe make that a size t, where it's the max proc count, defaulting to, well, I want to say 1, but in this day's purpose, let's just set that to 4 for now. But maybe I'll forget about it later. Huh? So compare the amount of processes in the queue with the max proc count. And if it is equal to the max proc count, so we would have to wait for one of them to exit first before adding another process. So that would be done by wait 1, taking B. And of course, wait 1 can mess with the value of build failed as well. So after this, we should also check if the build has already failed. I'm planning to make this. If one of the process returns unsuccessfully, it would mark the build as failed. The next order of business, um, appending the process. So I guess we can have uh, this would print the whole thing. So I guess a simple for loop would do. Say the command would be the first, and while the C is not equal to null, just keep on printing. The C and increment that by 1 and end that with a new line. But I can also add a check at the end where if C is not equal to null, instead of putting it in the condition of the while loop, since we also have to print a space between the arguments, and if it is null, then it's time to break out of the for loop, and no, the while loop. Then we can do the proc exec from here with the command variable. I know we're actually doing this wrong. It should be the double pointer. And this would dereference it. So it would execute it, return a process ID, then we can append it to be with the process queue and append PID. Now, the logic of wait one would be a bit more complicated. So, how should I go about this? I'm sorry for the burp if it's third, by the way. So, for wait one, we just take the build variable. So, I guess we should have a state where keep on checking. So, I guess continue loop. And the default value of this should be the opposite of if the build has failed. Well, if it hasn't failed yet, then this would return true. And if it did fail, it would return false. Thus, oops, invalidating this whole while loop and just return immediately. While inside this while loop, it would keep on looping with the process count and it would use the wait that has been wrapped by us. Proc wait. The process ID would be proc q indexed by I. And would this be a true wait? No, not really. Since we'll have to check if status is not equal to -1 and if the process has exited properly with status as the macro statement ending in a break if one of the processes already done. Then decrementing the count by 1. Now, how should I go about this? If it's a normal queue, well, you have process 1, 2, 3, and 4. Say if process 3 finished first, then the logical thing to do would be to move everything after 3 one spot ahead to make the queue a queue. Though this is not exactly the correct queue since we're not concerned about the order of the processes, just concerned about their status and it can be checked even when they're not in order, thankfully. So I guess if um process number 3 finished, we can just switch it with process number 4. We can swap it and when the vector count is decreased by 1, it would treat it as the final process, which is now the third process, to not exist. So I think we can go with that. So first of all, we have to take the process ID with our temporary variable. So we can just call that P, and it would take this current process queue. Now this current process ID And then, no, I think it would be better if I took the last. No, wait, how should I go about this? So I would change the current index to the last one with proc used. Well, that's still not right since I have to decrement 1 from that first, since it would index into nothing that has not been allocated yet. Then after that, I would switch it with the last one, proc q used -1 is equal to p. So I think we have swapped this successfully. And also we have the status here. And if it says that it has exited, it would set it even then if it did not wait properly. So it's fine. So I guess we can reset status to have a true wait. Of not the current process ID anymore, since that has been switched, but P in where we stored the current process with a true wait and check its exit status there. So status, and if it's not exit success, we'll take the build has failed, true. Also, this break is kind of wrong. Well, not exactly wrong, but we would also need to set continue loop to false. So if this did not exit successfully, the build has failed, and we can print it to standard error. Say process whose ID. No, the format for the process ID surprisingly is not cross-platform even in C, since Windows took a different path with this. So I guess a process did not exit successfully. Exit successfully. And it would just wait for other process to complete. Or just marking build as failed. And surprisingly, I think we're done with wait 1. Now for wait all, it's even easier. So it would take the build variable. So build b and just a simple for loop that would go through every single process in the so-called queue and waiting for it one by one. So in the status, we have nobita wait with the process ID once more. With this time, it would pause to wait and check if the process actually exited first. If exited, status. If this is not true, then it would set the build to be failed, then print a process did not exit successfully even after waiting correctly with the process, but it would not return immediately. Also, while the build has not failed it, since I do not want to print this multiple times, the same thing here. If exited, exit status. If the exit status is not equal to exit success, same thing. And after this, how should I go about this? The process queue used shall become 0. Now in build target, every mention of fork exec shall be removed. So building the object files, then building the target, well, building the dependencies, you should have a wait all after this. Since, well, we gotta wait first to build all of its dependencies before building this target specifically. Then every mention of fork exec will be removed with proc append and the build variable. Now after building every object file once more, wait for everybody. And then for the custom command, I guess I would not need to run wait first, but proc append would still need to be done. Now where's the mention of fork exec? There you go. Proc append. And in the mention of the custom command, well, use the custom command with proc append. Now maybe I should change this as well, since what I mean is to change if the process would execute if there's any source files at all. Else it would not be useful if the command has run with no source files. Same thing with the object files as well. So check if the sources is greater than 0. I should also add that here, since a true condition is just any number other than 0, and that's not what I want. Well, half of what I want. Now, where else that does this mention fork exec? Oh, in here. Well, I do not need to check here as that's defined by myself. So e dot and address of e. Oh, well, that is a bit anticlimactic. No, no, no. This would, well, I guess I can just make this wait normally. So wait with ID to true. Same thing would happen when re-executing itself. And I guess we're done with that implementation of multiprocessing. Well, I don't really have any projects to try this on. Well, that's amazing. Now I'm surprised that this did not dereference null, since in the main function, I did not initialize the queue, nor did I free it. The other thing is, while building the targets, I did not check to see if there are any processes left, since I do not wait for the process when the build target function is about to end. So run wait all into here and recompile this myself since it already errored out. So build Linux. No, should also compile this with asun. And let's remove cache and build and see what happens. Well, there's not much of a difference, but let's try to mark this as done for now. And we'll test this in the next video if it's actually multiprocessing. Now, how long did I take here? Surprisingly, 30 minutes. Well, thank you for sticking with me this far. And in the next video, we'll now tackle being cross-platform. Well, with Windows and Linux anyway. Now I wonder how will that go. Still, I thank you for watching.